So thank you so much for joining us, Giuseppe, for creating the course and everything, and thank you everybody who's here right now. We might have some of the people joining during the next 45 minutes.
Okay.
So to start with, hello and welcome to this webinar about Introduction to Intralogistics. This is put on by DIH². I'm Alex, head of comms at Is the Accelerator, one of the consortium partners. And in this webinar, I'm basically going to introduce right now the DIH² network, our purpose, and then I'll basically just take you through this resource that we're offering, which is part of the DIH² free services. It's free online courses, or MOOCs, about technological and digital skills, and these are designed to be useful for SMEs and individuals that are working in manufacturing and robotics. After that, I'll just hand it over to Giuseppe. He's our guest expert and the creator of this course and other courses, actually, but in this case, it's Introduction to Intralogistics, first part. And he's going to take you through the key points of to know what you need to know about this topic. And when he's done, we'll have at the end sometimes for questions and answers. So let's get started. Next slide. So in DIH², we believe in the power of robotics to transform the agility of manufacturing in SMEs and to drive economic growth across all the EU. And our role here is to facilitate the connections that enable agile production in factories where speed and versatility are essential to satisfy customer demand. Originally, it's funded by Horizon 2020. It's the European Union Research and Innovation Programme tasked with bringing great ideas from lab to market. And we, with DIH², we aim to generate innovation that maximizes productivity and optimizes agility in manufacturing SMEs and mid-caps all across the EU. And in addition, our goals include improving the cost effectiveness of advanced robotic solutions and driving growth of the robotics market. So we already have a large and growing ecosystem of organizations that have joined our network. And if you're interested in learning more, you just have to visit DIH². /squared.eu. So in the DIH² network, it's managed by a number of different partners from all across Europe, and each is playing a very different role. And in this case, us, ISDI, we are a digital business school based in Spain, and our role is to provide training courses that are currently open and free for anybody to access. So in this slide, you can see the target and goals. The objectives of this course, we're aimed to introduce users in the European manufacturing sector to new technologies and ways of work. So to teach how to implement those ways of working and ultimately support the update of innovation in manufacturing SMEs all across Europe. In our platform that we have with all the courses, you can view all of them. It's it's an online platform. DIH-square.mooc.ramp.eu. It's the URL there. You can browse all our catalog without even registering. But if you do actually want to take a course, you'll need to create an account, and that way you can access all the material that we have. It's pretty straightforward, so I don't think there's any complication there. There's a listing of courses, so you'll see we have a number of courses that are especially focused on technology related to manufacturing and robotics. But here you can have actually a better overview of what you have in the list and the different experts that have created these courses. And then also, in addition, we have a wide range of courses about digital skills, which aim to, help these companies bring knowledge into the modern world. So the topics are from agile methodology to data-driven marketing, interface design, usability, and much more. And basically, all the courses feature videos, text, slides, graphics, and some interactive learning experience. And also, some of the courses might even have a, like a test at the end or self-assessment. And the courses vary from, it can be from up to an hour to more or less 10 hours, but it depends on the topic. So yeah, this is the URL to access all the different courses. And yeah, now I'd just like to introduce you to Giuseppe. He's our speaker for today. He's a research scientist at Sintef Manufacturing in Norway. Graduated in mechanical and industrial engineering, and he's worked several years as an engineer in R&D production for leading manufacturing companies in Germany, UK, Switzerland. So today he holds a PhD in engineering with a major in production management and industrial logistics, and works as a research scientist at Sintef, which is actually one of the Europe's largest independent research organizations. And he'll be talking today about his course, Introduction to Intralogistics. So we're really happy to have you here, Giuseppe.
Thank you. I think I can even now share my screen. I could connect now differently,
Wonderful.
so it worked out.
Oh, perfect.
I'm happy for that.
Cool.
Yes. Can you see my screen?
It's loading. At least I see it all black for the moment, but oh, there we go. Here it is. Perfect.
Good. Thank you for introducing myself. And welcome to the course, like the webinar that we provide today for Introduction to Intralogistics. The course normally, which I have worked together with ISD, is that we have split up in Introduction into Logistics, autonomous intralogistics systems, centralized and decentralized intralogistics systems in practice, and planning control of autonomous mobile robots in intralogistics. So it's 4 parts, and we start quite on a high level, and then go more to practical as well in one of the interesting technologies. Today I will give just like a short brief as well about the course that we provide, and as well why maybe as well that topic could be quite interesting. Intralogistics is a term which I think in the last recent decade has been much more pushed as well, and mainly as well some of those needs which I show you, or like the trends which I show at the moment. Well, digitalization is nothing new, but I think when it comes to intralogistics, it's quite interesting because the intralogistics has been quite strongly as well from an automation side. But most of the technology has a quite strong standalone function, and a lot of providers just show their parts in it. But now with the increase of digitalization, we have a much better data infrastructure. It's well easier to integrate and as well communicate. So we have as well the opportunity to let different systems talk together, which as well improves as well towards a better integration and collaboration into logistics. Resiliency, we see that topic as well quite strong in new calls, but as well, especially in intralogistics, we have a lot of disruptions and crises from supply chain, chips crisis, or now as well energy. So we need as well some solutions that are as well helping us in our facilities working and managing that the materials are at the right time, at the right place. Circular economy has a quite strong impact, I think, in intralogistics, because we now have to integrate much more of the reverse logistics, which we have quite denied in the last years, to integrate much more high as well in our operations, in our facilities or in our production areas. So a lot of the return flows has to be integrated to a larger degree as well. Think how can we trace all the material that we keep as well a quality which is interesting. So we have to harmonize as well the forward and the reverse logistics, as well as think about how can we collect all data throughout the whole supply chain. And one of the supply chain parts is for sure the intralogistics. Decentralized decision making, that topic will be strongly in this course as well discussed, because I think we have more variability in the intralogistics, which we cannot all control. So we have to give away some of the decision-making processes. And this can help as well to get more resiliency, but as well to get more efficiency and so on. Sustainability, I see there quite a difference to the circular economy, because in sustainability we want to focus on the triple bottom line, line to be there in a balanced, good way. We focus more on circular economy on to reduce extraction and have a longer lifetime of materials and products. While in sustainability, we are looking as well about energy efficient, and there, for example, we see now as well forklifts with hydrogen and so on. So there's a lot of new topics which is coming as well in intralogistics. Finally, a topic which has been now strongly attacked in the last years as well, the human-centric production. We have as well, we can see that the operator is a quite valuable asset. He's quite flexible and quite smart, and we want to use his best strength as well in the production. But that means as well we have to keep him healthy. Mental health is important because absence of crucial people can have a significant impact of our production. And we have as well a quite older work generation as well in our companies, which have to find as well place to work with them. So I will give as well some trends, just like examples from digitalization in intralogistics. You can see, for example, this is a solution from Bossat, Smart Bin. We can see quite simple solutions, but they're used quite smart. Here you can see scale, which has as well a IoT possibility. You can connect to the cloud. And with the scale, you can first define one of the pieces, but it can all the time say how many parts are in the different boxes. You can have the boxes in production at the production line as well in the shelves. And you have a good real-time inventory of your whole production. That helps, especially to understand how to have the replenishment. You can improve that much better instead of having Kanban or something else. You can have it on a real-time basis as well to get as well much more quicker information as well when you need new parts. Further, it collects all the time information throughout the days or months, so you can have a much better analyze when are actually parts needed or why. So forecasting gets better and so on. So you have a huge possibility using quite simple solutions, but used and connected through the cloud. Decentralized decision making and material handling. We can see especially that in material handling at the moment, when you see this AMRS, the automobile robots, that we outsource the navigation. So the sensors, the technology is now in a quite good maturity that we leave him alone and say, like, you decide how to move, you find better the way than one centralized computer. And as well, if you think about in some of these warehouses, you have thousands of these robots. So they have to work on their own instead of have a centralized computer, which a lot of older generation of material handling system are doing, that is centralized decision making, which makes the system much more slower as well, not robust. Finally, as well, human-centric. An example here as well, we have now production lines which can adapt to the worker as well in height, giving the information at the right time, showing where he has to put the parts and so on. As well, throughout of the different production lines, you get information where the parts are. So we have a production line which is as well focusing on the human to provide him with the information which he needs, as well all the human factors adapting our ergonomics to his needs. That helps as well to get the material in a better quality, as well as improve the material flow as a final. So now I talked a lot about some parts of intralogistics, but what is actually intralogistics? There's many different definitions. But in the course, I think on the left side, you can see already quite some of the parts. But I think two good definitions are the organization, control, execution, and optimization of internal material and information flows, and the handling of goods in industry, distribution, and public sectors facilities. So you see there's a lot of interesting parts, which I can show us on the next slide. So first, in intralogistics, we are focusing especially in plant within walls, or like there's a clear boundary. Let's say like we are not logistics on the streets or like on transportation, freight transportation. The need for that one is because logistics is a quite wide range, and the ships logistics or maritime logistics is a completely different topic than the intralogistics with its items. In intralogistics, we're focusing really on an area which is quite bounded and not so huge. The next is that we focus especially on the material and information flow. And here you see, again, we want to combine physical and digital flows as well. You can see here that the need to cyber-physical systems is getting higher. We focus in intralogistics mainly in planning and control. So what decisions have to be made on a strategical, tactical, and operational level? How should we move parts from A to B, and so on, and to which time? Finally, we look as well about performance, and we have quite often we use the triple bottom line, which as well helps most to be sustainable. So we look at the financial, the environmental, yes, and social. That was the last one, sorry, and social focus. So here you get as well, again, the human-centric as well back, especially when you look at the social part. Automation in intralogistics, I think we started quite manual in the old days, but now we're getting much more automated. We have as well semi-automated systems. For example, you have in the middle shuttle-based storage system, which can make it quite compact, the storage, but you have still maybe a forklift, which is feeding it. You can have conveyors, which are quite automated, but give less flexibility. And we are now moving more and more to as well what we would like to call autonomous. What we mean by that is that, or what is the main difference by that one is as well that, as you can see in this compact storage plate, which for example AutoStore delivers, you have robots and vehicles on the tops, and they put the boxes or move the boxes or put them to the retrieval areas, and so you they shuffle the boxes around that you have always at the top. The high runners, more in the middle one, the boxes which are not so often used, and the one which you use less at the bottom, but you use quite this system in e-commerce. It's quite easy to build up. It's quite compact for the size. So if you have rented a place, you can use quite a lot of the space in height and in all different directions. And you have some places where you can hand out the product. So it's helping quite a lot about the material handling, and you leave the last part, which is quite difficult still for robots in material handling, is the picking, where you have then the human, which focus on that one. So the question is, well, like, why do we need actually autonomous system? Why do we should focus on that topic as well? Why should we decentralize some of the decisions and giving the systems their own possibility to decide? For autonomous system, it's for sure important that we give quite a range of decisions that they can do on their own. We can give the rules, we can set the rules, but they have the opportunity to decide on their own. As you see, for example, on the top left one, you will have systems which are working together, human and robots, or like AMRS, and both have their own will in that case here, and both have to adapt to each other. There are so many situations, variables, which we cannot predefine. So automated systems follow predefined rules, and we cannot predefine all the rules in all different manufacturing areas. That makes the new bigger topic why we need autonomous intralogistics systems. If we want to enter new application areas, new markets, we cannot predefine all the areas. We need systems which can learn. As you can see as well on the left bottom one, robots will as well work more and more closer together. Collaborating, you can as well use several AMRs maybe to transport. You can scale up the system much faster, and so on. So collaboration is another big important topic, as well as then what is quite still difficult is as well soft materials to grapple, like as well, especially fruits or something else like that. And you can see that on the right top part as well. And new markets, for example, in hospitals, especially with the COVID crisis or the COVID pandemic, we could see an explosion of AMRs coming in with quite interesting ideas, especially when healthcare workers as well nurses and so on, we're missing. There can be some parts which can be outsourced as well in critical situations. So what is the main difference and why we focus that one? So what we changed quite strongly is what we would like here as well to give in this course is like to think differently from centralized system towards decentralized system. We have quite a lot of systems in intralogistics which are still working centralized. Has as well something to do with the ownership of some of the providers from these machines, but we need to change that. We are depending on single nodes, which have a strong decision in the material handling or in the intralogistics systems. So moving from centralized towards decentralized, which is much more on the right, you have as well the opportunity to be more robust as well in times of failure or if a system is breaking down. For giving even a better example now, we have autonomous mobile robots, acquired a system which is quite interesting at the moment because we managed quite strongly to accept that we give him a strong liberty to navigate. It's easy to integrate, especially with the SLAM technology, simultaneous location and mapping. We can map quite quickly rooms, giving him a map to orientate, and with the different sensors, he can understand where it is, and we give him the opportunity to understand with Pathfinder with the different algorithms to find new ways where to go from A to B. But if you think about the autonomous mobile robots, is normally quite old. Like the first patent was 40 years presented, I think, 87 around. But in the last 10 years, it actually made its strong breakthrough in intralogistics. And I think one of the major points was that the battery got stronger. It can survive all the technology which has to be inside there to calculate, not consuming too much energy. But we have as well sensors as well processing devices which gets much smarter, focusing on different parts using less energy, as well that they can calculate much faster some of the points which they are. Because most of the AMRs are now working quite closely with humans or in areas which are quite dynamic. Before we had the older generation, what you would maybe go in between is the AGV, the automated guided vehicle, which you can see here on the left side. And there you had to predefine the guide path. So, and as well the pick and delivery station. So just to give an example, you have here, you can see the physical layer, a top view where you have the guide path. Sometimes it was a copper band in the floor. It could be as well some reference points and so on, but it was predefined and he could only follow those points. And if something was in front of this AGV, it would stop and wait until the part is removed. So if a person, it would just stop and start after some seconds. But if it would be like a pallet or something else, and it was in his way, he would just stop until somebody would remove it. He would maybe send a failure, an error after some minutes and say like something is wrong and somebody had to come and check what it actually is. So you can see that the system is quite sensitive to the environment, what's happening around as well. You could not find different new ways. With the AMR, we have now the opportunity to give him a map, as you see maybe on the right side, like the M is for machines at the moment, and he could decide on its own where to go, where to deliver. You can flexible define where to put and so on. What is, I think, one major change as well is how they decide, because normally you had in the AGV system that all the vehicles, they are connected to one control unit. So it gets the information that position 1 gets, there's a pallet or a wagon, which has a RFID tag and gives the information it has to be moved, for example, from P1 to P5. So the control unit checks where are all the AGVs, which one is idle, different rules about it, who should get it first. And then it would send someone, it would calculate the shortest path and it would send it there. But in this way, you have a totally sensitive system, because the more AGVs you have, the more things are happening. Everything is going back to the control unit. If the control unit has a small breakdown, all the system has a problem. With the AMRs, you outsource much more, you put much more you decentralize the decision making towards the AMR, to the single AMR. So it can communicate as well with the other systems as well to understand, and they're getting much smarter as well. That the focus is here as well to let all the AMRs talk with all the systems as well, let them understand where are the transportations needed or the deliveries, and they can negotiate. So they can negotiate with the other AMRs which one should get it, instead that one single control unit is deciding it, and the one who is bidding often the best would get it. So in this way, you can as well have as well new ways how you transport. You can as well combine transportation. You can give a cost for different transportations. And the one who has the lowest cost, for example, can get the transportation and those jobs. And if it's a breakdown, you can as well quickly communicate with the others and not jeopardizing what they're doing. So moving from AGV to AMR and decentralize the decision making supports really strongly as well to get that we get a much more robust system as well, working in environments which are at the moment quite dynamic. And this is the aspiration which we have as well. Currently, the AMR has only like the pathfinding, especially like the navigation, really strongly, the autonomy. But there's so many more tasks and operation which can be as well given to him, not only the navigation, but as well the job scheduling or like the job allocation. That would be, I think, in quite soon time as well, be much more decentralized than currently still centralized. But decentralizing the decision making makes a huge difference in how we have in the current frameworks. And this is a part which we as well discuss in the course, because our control frameworks, which we have been established in the last years, are changing. A lot of the strategic and tactical and operational decisions are moving or falling away. We don't need to think about guide path design longer. But we have to understand to which level we want to give the control to him. Which decisions should he take? Should he take all the decision? Parts of the decisions are still centralized, some are decentralized. As well, we look much more like in which zones he should work and not in which paths. So we have new ways to work as well. AMRs are much more flexible as well in when it comes to resources. It can as well change much quicker resources, equipment, and so on. We have as well the opportunity in some areas to have a continuous charging. It means as well like we have charging lines on the floor, and when it's driving above it, it's charging. Yes. As well, path planning gets a little bit more interesting because in AGVs, for example, the vehicle routing was especially to focus not to have like a deadlock, that it's not moving against another AGV, because if they're in one path, they cannot drive around. In path planning with AMR, you have a totally new opportunity to think, because obstacles like a pallet in front of him don't need to be actually a stop. If he has a forklift, he can as well move it to a different place, and then go further. So there are new ways as well to pass obstacles, as well to drive around, and to understand as well the environment, that by moving, I can as well overcome some obstacles. This makes as well a totally different as well when it comes to robustness and resilience, because the AMR can be much more as well proactive in this one. It can start much faster as well if there's a problem. AGVs mainly are in most AGVs systems which they're implemented in production or in hospitals, you have one worker who is assigned or responsible nearly 24/7 to look if it's working or not. And there's quite often failures, so they have to look, and they are there. With the AMRs, you have the opportunity to have less surveillance about them, what they are doing. They're much faster and much better to understand their problems and to find solutions for how to overcome them. And this is a quite advantage for that one. And you can see that a lot of the decisions are moving much more to the tactical and operation part. It means as well, it's much easier to and much quicker to integrate them. You had a lot of more tactical and strategical decisions to do with AGV, and the planning and the integration took much longer. The AMR, the aspiration as well here is to quickly scale up and to integrate them and put them in. And yeah. So as an example now in intralogistics, AMRs are quite changing traditional manufacturing systems. Let's go through them a little bit. Flexible car production. Conveyor belts were quite, like the conveyor was quite common in production for car. You had one long line in production that you could start at the beginning of the production, walking aside this conveyor, and you could see how it got manufactured. You can see now more and more that they are on a movable device like an AMR, and you can now have a totally different routes for them, how they work. You can have as well your layout of your production line can be totally different. Before it was like often a long line car manufacturing. Now you have the opportunity to have a quite flexible as well production. You can send it as well for if there's a problem to different areas to get fixed and quality checked. As well, if some products or some cars need some special treat, it can go special around for that one. So it's quite interesting to give flexibility in car production as well. Mobile collaboration. We'll see that as well. Mobile robots as well can share some resources as this robot arm, which is easy as well to collaborate, and you can use it in different areas. That's quite interesting in that perspective as well, that resources, equipment, you don't have to connect to single machines anymore. As well, you can have a helper in that sense in totally different new ways. The same for mobile manufacturing operations. One of the still quite intensive work are, for example, this windmill blades. They're really, really long, and the work to sand them is quite say that best the human fatigue is quite strong on that one. So it's, yeah, you have to work with a mask and all day in really special positions and to get it really flat. But you cannot have at the moment so huge robots who can survive all the length of the windmill blades. So you have here opportunities as well to integrate a mobile device to collaborate with another robot, and as well to find new ways how to manufacture and to provide mobile manufacturing operations. Further, AMRs are getting smaller and smaller. This is actually quite a good thing, in my opinion, because you can quickly integrate them in many different areas. A lot of production factories or assembly lines are quite compact, and large AGVs, which you had before, were mainly used to move pallets or bring products, but they were not integrated inside as well the assemblies. Now you have as well the opportunity to connect as well a lot of different machines and have as well a one-piece flow combining small boxes, which you maybe was doing before with a conveyor belt, but then you change maybe the layout of a production line after some years, and then you had to integrate so many more people just to change layout. And this has been always like a resilience changing layouts for the planners. But here with this flexible solution, you can combine a lot of different machines, a lot of production lines, much more easier, as well moving smaller parts and much more closer as well where the things are happening. They can as well feed, as you can see, there have a conveyor on top, like the small rolls, so they can feed and deliver. It's not only like just standing next to it and waiting that the box will be collected. So the integration of that one is much higher as well. AMRs is changing as well. Warehouses are quite automated, but you need quite a lot of variance or variability when it comes to the e-commerce. You can see here you're changing now how you move, how you do the warehouse. Not the person is going to the shelves. The shelves are coming from alone to the picker. So you have a lot of these, especially when you have a wide place to have the warehouse, which is really big, not in height, but like in length and width. And you have a lot of different products in a low number. Especially this type of system is quite effective. So the small robots are moving to the shelves, are picking them up and putting them online to the picking area, or picking bay, which you call it. And you have the picker. They get the light towards the shelf where they should pick the product, and they just do the parts which is still difficult for robots for the picking, to understand how they are sitting, how is the quality, and put them in the right box, which then will then further delivered. So here you have to as well, the shelves will put back then in this storage area, but you have a totally different new way to think that not the person is going to the shelves, but the shelves are coming to the picker, and he's doing what he's doing best in picking and understanding how to put it in the boxes. The same goes as well to other storage areas as well, where you have like a new ways where the robot can either follow the human and you just put the parts which you want to have, or you have the other way around, that the human have to follow the robot. The robot already is in the different lines of the warehouse, and you have to go where he's going and pick, and you get information. You can have as well a totally different system as well, that the workers are fixed in lines and the robots are moving around, and you are not dedicated to only one of those movable robots, but you can stand your line and wait until the robot is coming. You feed him, and so each operator gets one line, but a lot of robots are moving around and picking throughout the different lines. What I want to say with this is that the AMRs have changed completely how we do now warehouse, especially in e-commerce. There's a lot of different ways to fix the problem to get more efficient. That's quite interesting because a lot of as well the e-commerce is quite different. So it's quite interesting to see what type of solutions there are. Mobile sorting operations as well. You can see that there's a lot of kind of holes in the floor. So the robots are picking different packages and they're moving and tipping them into these holes. And so you can sort, for example, in some parcel centers where they have to go. So it's a different way as well how you can sort much faster than you have a conveyor where all are coming in, or you have a manual sorting system. Finally, you have as well a quite newcomer, which is an Exotech. Now it's maybe already 5 years, it's not so new anymore, but here the mobile robots, they can go actually vertical and horizontal. So it can move on the floor, but it can as well climb up the different storages as well, quite high, and pick the different boxes. So here we have a solution which combines the vertical and the horizontal movement. But again, all these solutions have different throughput times, how quick you can get the parts, as well. How is your storage area? Is it more flat? Is it more height? How compact is it? So it's quite interesting how it has changed in the last year as well with mobile robots. Then we can see as well that AMRs are coming into new areas, a topic which I have been working in the last years quite strongly, as well as AMRs in hospitals. We can see, especially through the COVID pandemic, that the interest and the acceptance towards robots has been quite good. Before, there was a quite a resilience about having robots in hospitals because people didn't want to associate robots or like production with hospitals. You should not feel like this is a manufacturing place, and you want to have this warm feeling that you are appreciated or you get like this help. But we see now that there's a lot of material handling activities which can be outsourced. As for example, on the left side, you can see there's a storage which is moved, a cupboard which inside there are sterile instruments. The sterile instruments is quite an internal strong movement of equipment along around the whole hospital. and they have a lot of security checks, has to be clean, sterile, a lot of different instruments. I don't think that so many, I have been in sterile processing departments, they have a lot of devices, they have to be cleaned, they have to be put at the right operation at the right time, and the quicker you can turn around the materials from the operating room to the storage and back and forward, the less instruments you need, and this is quite interesting for hospitals as well to save money. The more time you need to pick them up and to clean them, the more you need as well as to have in all the other ones. So it's difficult to share them. The next one as well is the UV light station. We know now that there can be some viruses and bacteria which can be not good for us and quite have a strong impact in our society. So we have a device which is quite expensive, the UV light, but it can in 12 minutes, it can clean quite strongly all the surfaces. And this is quite interesting if you have it in a mobile robot. If you can see on the bottom right one, you have the stationary solution. So before a healthcare worker was moving this inside, putting in the plug and waited 10 minutes, 12 minutes. But as you can see, you cannot spread the light in all different surfaces, and time is always critical in hospitals. So he will not stand and move it around. But with a mobile device, it can go through different rooms and be at certain areas as well, move from one room to the others as well. If it's connected to your system as well, you can give as well really quickly information when the room is ready. So to use mobile robots in hospital can as well give resources quite quickly free, like rooms. Then lastly, we have on the right one, which is from ABB, which tries as well to see that a lot of the lab work in hospitals are quite repetitive, or there's a variance in some, like they have to fill the machines or pick out the machines or move some of the probes around and so on, but it can be still outsourced, some of them. And so the idea here as well is to have a collaborator which can help to as well to do some work and filling machines and so on. So hospitals are getting quite interesting for AMRs as well. Next one is as well AMRs in agriculture. That's a totally different topic now. We are moving a bit more outside, but there the AMR is now working much more as well with GPS, not only with the SLAM technology, but as well using GPS or other reference point as well to find its place in a bounded area. The quite advantage is, as you can see on the left and the middle one, it's the device is much smaller than the actual agriculture devices. That's quite good for the soil because the weight of those machines is much smaller. You can have much more things more compact as well. You destroy much more less all what is around. And this is quite interesting as well to have equipment that can work and pick or remove some parts which is destroying that it's growth. So removing some of the leaves, for example, on the left side, can as well improve that the fruits or the vegetables can grow much better. On the right side, you can see quite something interesting as well, which is a Norwegian startup working on, because the strawberries, they can get in the beginning of the season like a disease. And normally you had to do it differently. Now you can use a UV light, which is like moving around through the different areas, and support that you don't need chemicals. So you make as well the products. So AMRs can as well support that we have much less chemicals in our food, which is quite interesting again, much more organic, and yes, in that way. Then we have as well AMRs in different application areas, such as inspection surveillance services. We can see that warehouses has been sometimes been interesting to to get inside at night, but you cannot have there 24/7 somebody, which can be expensive. But those moving devices, which moves in warehouses, can quickly detect if there's somebody inside. So you can use them as well for surveillance and check if there's somebody coming in, but as well to understand what is your inventory level. So there are several companies which try as well, for especially for supermarkets and so on, or warehouses, to understand how much products are at the moment in the shelves. So you have a quite updated everyday system. It's quite still difficult to get a real-time inventory of supermarkets, but we are getting closer to that one, which can then again improve our orders, and as well the shelf, the lifetime of the products can be improved, that we don't waste so much food as well. So that's quite interesting that we have those flexible solutions which can move through the aisles and collect the data. What we can see as well is in oil platforms that we get these interesting AMRs, which have as well feet to walk, climbing stairs and so on, going to different areas which you normally need protective clothes or so it's interesting to send those in from a time perspective as well as from the place where they are working. Some of the oil and gas platforms are quite far away, so you have to plan quite in advance as well. Some of those inspections and surveillances with humans, so you have to, if the weather is then bad, you have then to reschedule it. But so you have to come with the helicopter. You have to get this protective clothes and go to those areas. Sometimes they have to be shut down for as well safety issues, and then they can do the monitoring or checking if all the machines are in a good condition. But nowadays you have the opportunity here as well to send AMRs. You can as well from remote as well have a live video transmission as well to understand what is happening. And they can collect as well data as well with the sensors as well. They can as well see through vibration or like the sound as well to get more information, which is as well difficult for the human. But they can do it much more often. So there's quite a lot of topics which they can go on their routine around in those areas, especially for inspection and surveillance services. Then finally, this is my last slides before we can have like some questions and answer session. We are going towards quite a lot of new areas. Some will be a little bit new to adapt. I think still in restaurants, it seems a little bit strange to have AMRs, but I see that some have already started here in the city where I live with AMRs, especially they look a little bit like a cat. So a lot of children are really liking that they are be served of this robot. So you have maybe as well the opportunity to attract a lot of new people as well, but as well the delivery of some of those can be quicker. You might can as well for a small restaurant might be able to have the opportunity to start quicker with an AMR than checking first to establish your waiters. So that's as well another opportunity. Yes, especially in the COVID time, it was as well restaurants, they need to have as well space between as well. The workers are in contact with a lot of people, so it was always difficult as well to help them in this period. So it can be as well a solution, especially for some areas which are quite impacted of a crisis, or yeah, so it could be an interesting solution. It could be as well interesting for hospitals. Let's see where they are all going. The next one is car parking. I think car parking sounds in the beginning not like this valet, not so interesting, but the opportunity is here, especially I think for airports as well, where you have longer distance, you can have them a little bit more far away, the cars, but as well, you can store them much more compact. So you have the opportunity like a puzzle. I don't know if everybody remembered like this puzzle which you had where it's like one piece open and you have to move the parts. So you can think like that as well, that there are some puzzle-based storage systems, quite interesting publication as well, how the algorithm should be, or how the principle should be to have like a puzzle-based storage system, which is quite compact. As well in some dense cities could be quite interesting to have like parking spots, which is then using those robots to move the cars and have a really dense, compact storage of cars. And we have as well hotels on the right side. Hotels can provide new services, and I think this is one which I have been in contact with several ones. They're quite interesting in providing in new services because it's not often that somebody maybe orders something, but it's quite interesting at some certain hours to deliver part that they can request and they can get it. And that you don't, because a person who is in the at the reception, they might have to walk quite along to deliver the parts if needed. So the reception at night can be quite vacant empty for a long time period. But he can fill it at the reception with the parts which the other people are ordering, and so you can deliver it quite easily. When it's in front of the door, it gives a sound and opens the door, this on top, to deliver the part. So to sum up, decentralizing the decision making can give a lot of opportunity on how we do business, how we do production, how we do deliver services. It can as well change completely how we do production or warehouses in the future. But we have to start to think a little bit how has to be everything connected, that we get as well a robust system, that we have a good data infrastructure behind it as well. But there's a lot of opportunities. So I think in this session, especially in the webinar as well in the course, I'm really like to focus on, okay, what is really needed, but as well, let's be more creative, open up a little bit the eyes, what are the possibilities as well. This is a course for the SMEs as well, especially opening a little bit up to get a little bit more creative as well, and to understand that intralogistics can be quite interesting. There's a lot to get, a lot of opportunities, a lot to be more efficient. But we need as well to understand how can we outsource or decentralize some of the decision making, setting up the rules in the right way, that the system can work robust and efficient. Yes. Thank you for listening today.
Thank you, Giuseppe. We do have one question from
Yes,
Dennis.
please.
Not sure if you can see it, or maybe you did answer it, sorry, but he was asking if you've ever seen decentralized decision-making task allocation for MARs in production.
Not physically. I know we have a company here in Norway, which is called WheelMe, which is quite innovative in that sense that they are providing wheels. I think I have even a figure of that one, which is quite interesting. I think they are quite closest to that one at the moment. It looks like this one here you have on the left side. You have just the wheels, so you can put them on the machines that you would like to have, on the table or on the cupboards, whatever you want. And on the left next to it, you can see as well there's the charging. So this is a quite where you really have only like just move as a service. And I know we have been talking with that company quite strongly when I'm doing during my PhD as well. And there was as well that we were talking about decentralized task allocation. And there you have to work then with bidding algorithms. But we can still see that the majority is working with a centralized task allocation. But as I think the transformation towards a decentralized job allocation we will see in the next 5 to 10 years. I think I'm not 100% sure. I was wondering when I was preparing the slides as well if Foodora or like all the others are doing more decentralized as well already. I think we can see that not in intralogistics, but like in other delivery services, I think they have much more already adapted those initiatives or like this thinking as like food delivery. I think they're much more advanced. I think some of those ideas, how they're doing that one could as well be used normally in the intralogistics in production. To think about, there are so many equipment which can transport. As you can see on the top left one, you have a AMR and you have a forklift or somebody else who can. If a small part has to be transported, normally it should be just announced in a system, and one of those two should just decide which one is idle, which has free time and can pick it up. But at the moment, it might be much more centralized that one of the system gets the job and then it will be allocated. So I hope that it moves towards decentralized more and more, and that we see that more in the future.
Great. Sure, if we have any other questions from anybody of the attendees. I mean, you guys can write it down or
Yes.
unmute yourselves, so whatever feels. And if not, Giuseppe, maybe let me just share the last couple of
Sure.
slides from my presentation, and we'll wrap it up.
Mm.
Cool. Yeah. I've been muted all this time. I just realized. Sorry, I was just saying that we've got, a few webinars coming. So I'm so sorry, it's so stupid, but we've got a few webinars coming up. That we basically share the links for you guys to sign up on ISDI Accelerator's Twitter and LinkedIn profile. These are the next webinars happening in the following weeks. And we invite you all to register to the MOOC platform so you can take the courses. Here is the accelerator. This is our profile, and this is the URL for you guys to register to the courses, and that will be. Thank you so much. Thank you, Giuseppe, for your time and all that detailed explanation. And see you next time.
Yes. Do you have quickly a second? Can I ask you something?
Oh yeah, absolutely. I mean, I'm not sure if you want it outside, of the webinar, or is it like webinar related, of course?
It's not. It's about the next webinar, but we can as well have it.
Oh, okay. Then I think let's